will see three-phase connection. How it is possible that the three-phase supply is transmitted only with the help of three conductors, not with the help of four or six. See, you can imagine if we have single phase supply, we have phase and neutral. Barabar? So why for three phase we have three phases and three neutral? Why it is not there? For single phase we have one phase and one neutral. बरं म्हणजे आपल्याकडे थ्री फेज असेल तर तीन फेजेस आणि तीन न्यूट्रल पाहिजे ना प्रत्येकासाठी वेगळं. तर तसं नसतं. That is because three phase connections are there, which is a star and delta connection. By this connection, it is possible that we can transfer electric three phase power with the help of only three conductors or max to max four conductors. It is possible only due to these connections, star connection and the delta connection. So these are very famous connections in case of solving networks or in case of the three phase connections or three phase supply system. Now look at that. First of all, the star connection. How this star connection is formed? Very simple. The star connection is formed by connecting. Where is the pointer? Star connection is formed by connecting each end of this individual phase connecting together, which will form a common point. Look at this common this end point of each phase. Let us we have phase A, B, and C, or you may consider R, Y, B. These separate phases we have, and what we are going to do, we are connecting the end point of this R, Y, B phase together. This will form a common point, and in the star connection, this common point is called as the neutral point. Right now, let us we have just arrange this diagram in the form of a star, which is looking like a star. So look at that. This is our usual R phase like this. Then we have the Y phase. We have this phase B. Right. So this is the starting point, as we have point number 1, which is at here connecting to the terminal. Then point number 1 for Y phase, which is connecting to the terminal, and B phase connecting to the terminal. And look at that common point, point number 2 for each phase, which are connecting together. So this will form a common point, and this is nothing but the neutral. Look at very simple. प्रत्येक फेजचं एंड पॉइंट एकमेकांना कनेक्ट करायचं, एक कॉमन पॉइंट तिथं तयार होईल. तो कॉमन पॉइंट म्हणजेच जंक्शन किंवा न्यूट्रल आपण त्याला म्हणतो स्टार कनेक्शन. आणि हे स्टार सारखं दिसतंय, 3 साइड आहे त्याला, बरोबर, 3 ब्रांचेस आहे, म्हणून याला स्टार कनेक्शन म्हणतात. आणि जो जंक्शन पॉइंट आहे त्याला न्यूट्रल. राइट. सो दिस इज द स्टार कनेक्शन. Now delta connection, you know the Greek word delta. So this connection looks like that Greek word delta, hence it is called as the delta connection. Now look at that, how it is formed. By connecting the end point of first page to the starting of second, see, or you can have the end point of first to the starting of second, or you can have the end of second to the start of third, and end of third to the start of first. So this is you can have, suppose this point is the end point which is connecting to the start of second. At this point, the end of second which is connecting to the start of third, and the end of third which is connecting to the start of first. So this will form a closed loop, and when we arrange this in a systematic manner, we can have a delta like symbol which is formed. Hence it is called the delta connection. Now look at that. This first point that we can have, one point is connected to A, the second point which is connected to start of second. Look at that. This first point is connected to A, which is second point, yellow, start of that yellow. Then this point B at B, where is that? So there is L, yellow, and the blue. So look at the end of yellow and the start of blue. And similarly the third point C, which is what? The start of blue and the end of red. So this form a closed loop, and the each terminal which is connected to supply. Yes. any issue? येतोय ना आवाज?
Yes, sir.
Yes, sir.
बस कोणतरी हॅलो म्हटलं.
Yes, sir. येतो.
So this is the delta connection, right? So this look like a Greek word delta, hence it is called a delta connection. If you observe these two connections, then the output conductors are only 3, or you may have in star connection the port conductor, which is the neutral. So this is the addition to the third phases, right? So fourth wire will be of neutral. So you can have this first R, this we can have B, Y, B, right? And the next one is the neutral. So 4 wire connection, which is for star, and 3 wire connection, which is for delta. So these are the two very famous connections for 3-phase supply. So all the 3-phase appliance, all the 3-phase load generators, which may be connected either star or delta, not excluding other connections. जे काही डिव्हाइसेस आहे 3-फेज जनरेटर असेल, मोटर असेल, लोड असेल, वेगवेगळे अप्लायन्सेस असतील 3-फेज, ते एक तर स्टार कनेक्शन मध्ये असतील किंवा डेल्टा कनेक्शन, या दोनच कनेक्शन तिथं पॉसिबल आहे. याच्याशिवाय तिसरा कुठलं कनेक्शन नाहीये 3-फेज मध्ये. So when you see any device, suppose for example, if you have industry, or if you have any what we have workshop, then you are using 3-phase induction motor, 3-phase motor, then you can just see the nameplate or the specification for that motor. You'll observe that there will be either star connection or delta connection, right? Okay. So the next thing is balanced and unbalanced load. Now we are considering the load which is connected in either star or delta connection. Okay. Now let us have the star connection. Now what is balanced load? Very simple. When the impedance across each phase is equal, then it is called balanced load. When the impedance across each phase is equal, then it is called balanced load. Or we can have mathematical form Z1 is equal to Z2 is equal to Z3. What is Z? Z is the impedance, which is a combination of resistance and reactance. Every load, every electrical load, which will be either resistive, inductive, capacitive, RL, RC or RLC, याचं काहीतरी कॉम्बिनेशन असणार आहे. कुठलाही इलेक्ट्रिकल लोड हे रेजिस्टर, इंडक्टर, कॅपॅसिटर याचं कॉम्बिनेशन असणार आहे. बरं, मग कुठलं मोटर असेल, कुठलं कॉइल्स असेल, हिटिंग एलिमेंट असेल, वॉट एव्हर, which will be the combination of RLC or any of these two, or maybe only resistive, right? So we can just represent this load in terms of the impedance. Very simple. It may be resistive, inductive, capacitive. We'll just simply indicate by the impedance. So if Z1 is equal to Z2 is equal to Z3, then we can have balanced load. म्हणजेच काय, प्रत्येक फेजला इक्वल लोड आहे. सिंपल. जो लोड R ला आहे तोच Y ला आहे, तोच B ला आहे. व्हेरी सिंपल. जर 10 किलोवॅट Z1 असेल, 10 किलोवॅट Y ला असेल, 10 किलोवॅट B ला असेल, इक्वल लोड. व्हेरी सिंपल. इम्पेडन्स इक्वल म्हणजेच काय, लोड इक्वल. Right? Now unbalanced load, now you can simply define it. When the impedance across each phase is not equal, then it's called the unbalanced load. Unbalanced phase. It is called unbalanced load. Z1 not equal to Z2 not equal to Z2. These impedances are not equal.